Hey everyone, thanks for joining us. I am Paranjay and along with our team, Manthan, Shantanu and Shreyas and me as well. Today we are bringing you a small presentation on the topic Docker and containerization and as well as Kubernetes. So you hear these buzzwords thrown around constantly in tech right now, like cloud native, microservices, containers, orchestration, etc. But cutting through these jargons, what we are really talking about today is the modern standard for how applications actually get built, shipped and scaled in real world. So without everything completely breaking down in the architecture. So I will be kicking things off by laying down the foundation and like explaining containers and Docker. So let's move on to the next slide. So first things first, why do we even need containers in the first place? Like what is the need? So let me paint a picture for you. Have you ever spent hours coding a project and it runs like completely flawlessly on your laptop, but the second you send it to your teammate, it like collapses or it crashes? That is a classic problem. It happens because of different operating systems, clashing software versions or missing environment variables. So containers were invented to kill this exact problem. A container basically wraps your application and absolutely everything in it, like the code, the runtime, the libraries and the settings into one single file, like a secure box. If you look this comparison on the screen, you can clearly see that the industry relied heavily on virtual machines, but VMs are incredibly heavy because they require a complete separate guest operating system to run on, which eats lot of RAM. But containers on the other hand share the host system's operating system. Like they are incredibly lightweight, usually just a few megabytes as compared to gigabytes in virtual machines, taking up the RAM much more. So this gives us two huge benefits, consistency and isolation. So consistency means container behaves exactly same on my operating system like Windows, Mac, etc. Isolation means if one container crashes or uses too much memory, it is just cut off and like it won't take down the rest of the server. So moving on to the next slide. So now let's move on to Docker. When we talk about containers or the tech world talk about containers, 99% of the time they are talking about Docker. Docker is essentially the engine that provides this whole container revolution. Think of Docker's workflow in these three steps. First is build, then ship and run. In build, you write a simple text file called Docker file. You can see a quick example on the slide here. It acts like a recipe. If we take an analogy of kitchen, in this example we are telling Docker like to start with a base Node.js environment, set up an app folder, copy the code I have written like my code into it, run npm install to get my dependencies or the variables, environment variables, etc. And then start the app. So Docker takes this recipe or the text file and bakes it into an image, like it creates an image out of it, which is basically nothing, a static blueprint. The next thing you do is you ship. You take the blueprint image which we generated just now, and then we send it or push it to a central registry. You can think of it like as a library, like a GitHub repository for Docker images, or we can call it a Docker hub. And then you move on to the next and the final step, which is run. Anyone, anywhere can run this image. It's like playing Lego with software development. You just have to snap the pieces together. So anyone anywhere can run the application using the image after pulling and pushing it in their computer. So moving on to the next slide. So to wrap up with my section, let's peek in a little bit more, like how the Docker engine actually gets all of this done. So the architecture relies on a standard client server model. So basically first is the Docker client. If we just simplify it, that's just you and me typing the commands in the terminal or writing the codes like docker run or docker build. So if we take an analogy of a restaurant again, you can think of it like as a waiter. Okay, so it's like taking your order, the client server. Okay, and then the second is docker host, also known as the daemon. Like this is the heavy lifter, or you can call it like when you place an order at a restaurant, it goes to the kitchen. So basically you can take it as the head chef of the kitchen. So the daemon listens to the client's order and does the actual hard work of building, running and monitoring your containers. Then we finally have registry. Going back to our restaurant analogy, if the chef needs a specific ingredient that they don't have, they go to the pantry, right? So the registry is Docker's pantry. If you tell the daemon to run an Ubuntu container and it doesn't have a Ubuntu blueprint locally, it will automatically reach out to the registry, download it and start it up for you. So you give the command, the daemon does the work, the fetching blueprints from the registry when needed, etc. So that's how Docker runs under the hood. So alright, that covers the foundation of running a container, like running an app in a container. So but what happens, like if you are a big company like Netflix or Spotify and you have tens of thousands of these containers running at the same time? To answer that and talk about the orchestrator, I am going to hand it over to Manthan to introduce Kubernetes to you all. Thank you for watching.
Hello, this is Manthan Sharma and I will be talking about Kubernetes, which is often abbreviated as KATS, which is commonly known as operating system for the cloud. So Kubernetes is an open source system designed to automate the deployment, scaling and management of containerized applications. So in modern software development, applications are often packed into containers using technologies like Docker. So containers allow developer to package an application along with all its dependency so that it runs consistently across different environments. However, when application grows larger, organization may need to run hundreds or even thousands of containers across many machines. So managing such a large number of containers manually becomes extremely complex. So this is where Kubernetes comes in. Kubernetes helps organizations automatically manage containers across multiple machines, making application deployment faster and more reliable, and also it is easier to maintain. Now let's understand about orchestration. It is one of the most important concept in Kubernetes, which is container orchestration. So orchestration refers to the automatic management, coordination and scheduling of containers across a cluster of machines. For example, imagine a company running a web application that requires 50 containers to handle user traffic. If the demand increases, the application may need 100 containers instead of 50. So instead of manually starting and managing these containers, Kubernetes can automatically deploy containers, distribute them across servers, and scale them up or down depending on the demands. And also it can monitor their health. So this process ensures that the application runs efficiently without requiring constant manual management. So in simple terms, Kubernetes acts like a manager that coordinates and controls all the containers in a distributed environment. Now let's understand about self-healing. So another powerful feature of Kubernetes is self-healing. In traditional systems, if an application container crashes, an administrator must manually restart it. However, Kubernetes automatically detects failure and fixes them. So Kubernetes can perform several self-healing actions such as restarting containers that fail, replacing containers that stop responding, and rescheduling the containers on healthy nodes. And also, it also helps in killing containers that do not respond to health checks. For example, if a container is running, a website crashes unexpectedly. So the Kubernetes will automatically create a new container and replace the failed one. So this ensures the high availability and reliability of the applications without requiring manual interventions. Moving on to the now let's move on to the core Kubernetes objects. So to understand Kubernetes better, we need to look on some core Kubernetes objects which act as a building block of Kubernetes cluster. The first one is pods. So the first and most basic object in Kubernetes is pod. So basically pod is the smallest deployable unit in Kubernetes. It represents a single stance of a running process in the cluster. So a pod can contain one or more containers that shares network resources, storage resources, and IP addresses. So the container within the same pod can communicate easily with each other. For example, a web application might include one container running the web server and another container handling the logins. So when the both containers can run together inside a single pod. Now the second one is services. So in services in Kubernetes are temporary and dynamic. They can be created or destroyed frequently. Because of this, their IP addresses changes. So a service provides us a stable way to process or access a group of pods as a network service. In other words, instead of connecting directly to individual pods, users connect to the service and the service forward traffic to the correct pods. So this ensures that the application remains accessible, and if the pods are replaced or updated, it will be accessible to the user. Now, moving on to the deployment. Another important object in the Kubernetes is deployment. So it is basically like managing and controlling the pods automatically. It allows developer to define the desired state of application, such as how many pods should be running. For example, if you specify that 3 pods must always be running, so Kubernetes will constantly monitor the system. If one pod fails, Kubernetes will automatically create a new pod to maintain the required number. So if I have set the limit that 3 pods should be running, so Kubernetes will manage the health and will see if the pod is failing. It will create a new pod, so the required amount does not break. So deployments also help in updating applications smoothly without downtime. So which is very important for production system. Now let's move on to the Kubernetes architecture. So the Kubernetes architecture is mainly divided into 2 major components. First is control plane and the second is worker node. So the control plane acts as a brain of the Kubernetes cluster. It manages the entire cluster and makes global decisions. The control plane includes several components like Kube API server. So this is the main communication interface between users and the Kubernetes cluster. The second one in etcd, it is a distributed key value database that stores all cluster data and configurations. The third one is kube scheduler. It is responsible for deciding which worker node should run a newly created pod. The fourth is kube controller manager. So this manager ensures the cluster maintains its desired state that we have seen previously. In simply terms, the control plane monitors and manages the cluster overall operation. Now moving on to the worker node. The worker node are the machines where the actual containers are and applications run. So in each worker node contains several components like kubelet, an agent that communicates with the control plane and ensures containers are running properly. Kube proxy, which handles networking and communication between pods and services. And the third one is container runtime, software used to run containers such as Docker and Container. So while the container plane makes decision, the worker node executes the task and run the application. So to conclude, Kubernetes has become one of the most important technologies in cloud computing. It provides powerful capabilities such as container orchestration, automatic scaling, self-healing of applications, and efficient management of distributed systems. So by organizing containers into pods, managing access through services, and controlling applications with deployments, Kubernetes simplifies the process of running large-scale application in the cloud. Because of these features, Kubernetes is widely used by companies around the world to manage modern cloud native applications. So now we have understood the basics of Kubernetes and its architecture. I will hand it over to Shreyas, who will explain why orchestration is important and why we actually need Kubernetes in real world system. Thank you so much for watching my video.
So imagine this. You have built an app, it works perfectly on your laptop, you deploy it to a server, after a few days your user base grows, traffic spikes, and boom, your single server crashes. Now what? Do you manually log it into 10 servers, copy your app, and hope nothing breaks? No, right? So that exactly the nightmare orchestration is trying to solve. Orchestration simply means automatically managing your computers across multiple machines, right? You can think of it like a traffic controller at a busy airport, which manages all the planes. The same thing orchestrator do. So orchestrator have many parts of it. Three most important are scaling, rolling, and service discovery. If we talk about scaling, so you could say that you have an app and on which a average 100 users comes, but suddenly a 10,000 user spike, user just bombarded on your app. So what this orchestrator does is that it expands, right? It expands the servers. It goes from two servers to 10 servers if the load increases, right? And as the load decreases, it just reduces from 10 to again 2 servers. Another is the rolling update. So ever wondered how Swiggy updated the app without going offline? That's how it does. So that is known as a rolling update, right? So instead of shutting down everything and pushing new code, it updates the container one by one, so keeping the rest running so user never see a maintenance mode page. Another is the service discovery. So in our big app, you have seen a login page, a payment page, a cart page, and so many pages. So did you want to know that how a payment page sees that what the user has ordered and how much money I need to take? So that also orchestrator handles, right? It saves each and every page, give it a name, and it's just like a contact book for the app. So in short, orchestration is what keeps your app alive, fast, updated, without you babysitting the servers at midnight. Okay. The another one is it's a battle between a very two big names, the Kubernetes and Docker. So let me give you one analogy that will make it a very crystal clear, right? So Docker is like a tiffin box. You pack your food, on here you pack your code, libraries, settings, everywhere, everything into a neat uh, tiffin box, and now you can carry it anywhere: your home, your college, a server in Mumbai, a cloud in the US. And when you open it, the food is exactly the same. So that's what Docker does, right? So it's a it containerizes your application so that you can carry it anywhere inside of the world, right? So what is Kubernetes then? So Kubernetes is the tiffin delivery system. It helps to manage your tiffin, right? So that it doesn't get break or spoiled, right? So it manages hundreds of those tiffins. Kubernetes has a capability to manage hundreds of tiffins. It helps to carries it from one place to another. If one breaks, it replaces it. It adds more delivery staff when order spikes. So it is just a managing system for tiffins. So they work together. You build a package on your app with Docker, then you hand it to a Kubernetes, which take care of running it reliably across the servers. So one line to remember: Docker runs containers and Kubernetes orchestrate them. Another is a deployment flow, how your code deploys so that everyone can use. So the first step, you code, right? Basically you code and you deploy your code to any online website. For example, let's say you deploy it in a repo on the GitHub. After that, you built in Docker image. So Docker image is like a simple text file. In which you describe that use this Python version, use these libraries, copy my code, run this few commands before building my code, and so on things, right? After that, you push it to a registry. So registry is basically a storage room for Docker images. The most common one is the Docker Hub. It's just like a GitHub but for images. After that, you deploy it to the deploy with the Kubernetes, right? So Kubernetes handles multiple of these images and just helps to keep that Docker alive and safe. Now doing this manually every time is very difficult, right? So what we do is that we use CI/CD pipelines, which are continuous integration and continuous deployment pipelines. So what these pipelines do is that whenever you build a new version, you don't need to just manually do all these steps. The CI/CD pipeline will do these all steps. So basically, what is CI/CD pipeline? Just a basic text file in which you define these steps and you just run that file every time when a new version releases, so that it just checks, deploys, and do everything on that version of that software. So the full picture is that that's the modern deployment, and that's how the app you use every day. Zomato, Flipkart, and even banking app, they stays 24 hours 7 online just because of this flow.
Few shares for explaining how Docker and Kubernetes works in real production systems and how they simplify the deployment process. Now I would like to take this one step further where I will be introducing you Docker Hub and Docker Swarm and real world scenarios and where Docker and Kubernetes are used and some future trends. Let's start with Docker Hub. Docker Hub is provided by the Docker and its world's largest library of containers and images. You can think of it as Docker, GitHub for Docker images, where developer can push their own image and pull the shared images by the others. This makes development much faster, and because you don't have to build something from scratch. For example, if you want to use an existing image, you can simply run the command docker pull command followed by the image name, and Docker will download it for you. This makes it significantly simplifies the process for building and running the containers. Now let's talk about Docker Swarm. Docker Swarm is a native clustering tool and the orchestration tool also provided by the Docker. It allows you to manage and scale containers across multiple machines as a single system. At this point, you might be wondering if you have Docker Swarm, then why you need the Kubernetes? So the main difference between Docker Swarm and the Kubernetes is scale and complexity. Docker Swarm is ideal for small projects and for simpler architectures, and it is easy to set up and lightweight and works well for quick deployments. However, if you are building something large scale and complex systems with multiple services, then you need Kubernetes for it because it has some advanced features like auto scaling and self healing and efficient resource management. Uh, Let us see some real world scenarios where Docker and Kubernetes are used in production. So the first one is microservices. Many modern applications are built using microservices where the system is divided into some smaller independent services like payment service, analytics, and inventory service. Each of these runs independently and can be scaled independently. So how Docker help us in this way? Docker allows each service to run inside its own container and ensure consistency and easy deployment. And when it comes to managing these services at scale, Kubernetes ensure that it is properly distributed and automatically scale and are able to recover from failures. The second one is multi-cloud strategy. With Kubernetes, you can run same deployment configurations across different providers like AWS, GCP, and Azure, etc., without changing a single line of code. This remove an extra dependency on a particular single cloud service provider, and it ensures the system's reliability, and also it reduces downtime of your application. Then the third one is CI/CD automation. Every time developer pushes a code, automated pipelines are triggered, and these pipelines build container images, run test, and deploy updates to Kubernetes automatically. There is no manual step, no delays, just fast, consistent, and reliable releases. The fourth case is edge computing, where you can use lightweight Kubernetes distributions like K3. Applications can be deployed closer to the users or on IoT devices. This reduces latency and enables the faster processing for real-time applications. Hmm. Now let us see some future scenario trends of Docker and Kubernetes. The first one is WebAssembly. It's also known as WAMS, WASM. Sorry to spell, I can't. Sorry for it. It enables ultra lightweight workloads that start instantly and use fewer resources than the traditional containers. This allows developers to build a high performance and securely sandboxing the applications. The second trend is serverless architectures. Tools like Knative extend Kubernetes with the scale to zero capabilities. This means when the application is getting more traffic, it will scale up, and when the application is getting less traffic, it scale down. This will reduce a huge cost for running the applications. Then the third one trend is AI and the machine learning. Platforms like Kubeflow bring machine learning and workflow directly into Kubernetes. With GPU orchestration, Kubernetes can efficiently handle high performance and large scale AI systems. So overall, Docker and Kubernetes are not just tools; they are foundation for modern and scalable uh, efficient cloud native systems. I hope you have learned something new from our presentation. If you have any doubts regarding this, you can ask in the comments. Thank you for watching the video. Bye bye.